I guess week 14, we're nearing the end. We're looking at lesson 112, 113, and 114 this week. So those three lessons. So let's go ahead and get turned over to lesson 112 in our book. Now this one, we're looking at multiplying and dividing integers. So first we got to remember what is an integer. So all of our whole numbers and their opposites. So a whole number is 0, 1, 2, 3, 4, 5, and then the opposites, meaning the negative of those. So -1, -2, -3, -4, -5, and continuing on. Not fractions, not decimals. Like 3.5 is a rational number, but it's not an integer. It's not a whole number or an opposite. All right, so again, we talk about this in the book. I don't personally love how they overuse parentheses, and then to make a positive number, they put parentheses +3 +4. I think this looks kind of confusing, whereas if I just told you what's 3 times 4, you'd probably give me the answer without even thinking about it. 3 times 4 is 12. Right? So they do it because they want you to see that this is a positive integer, and this is a positive integer, and that gives us a positive solution. Okay? So when I rewrite it and I do it on the board, I'll oftentimes not include the parentheses, and I definitely won't include, if it's a positive number, just write 3. We don't write +3, we just write 3. And I'll also show you when we do it in our calculator, if we overuse the symbols like they do in the book, we're actually going to get an error message in our calculator. So what I mean by that, if I do like they have in the book, okay, I get an error message. Well, I can't do 3 times 4. Yes, you can. It's just what the calculator is reading is plus, we're adding something to 4 that isn't even there, and there's nothing to add to 3. So simpler than that, we just need to do 3 times 4. If there is no signage as far as a positive or negative, we know that it's positive. Another thing on the calculator, a little side note, when we're making integers or any numbers, negative, we need to use this symbol down here. I know this is a negative sign, this is a negative sign, same thing. Yes, I know when we're writing a negative sign on paper, it's the same thing, but our calculator computes it differently, so just be aware of that. So if I'm doing like 3 minus 2, I use this one, gives me 1. If I'm doing 3 times -2, I do 3 times, and then I make the -2 using this one. That's -6. If I accidentally use the wrong one, 3 times -2, we're going to get an error message because it's saying, well, you're trying to multiply something that isn't there and then subtract. So you get an error message. Sometimes you get error message because things are undefined and you can't really do it. Other times you're getting an error message because it's not computing what we think it needs to. So just be aware of that. Okay. When we're looking at these, again, a positive times a positive is a positive. A negative times a negative is a positive. So a way we can figure out without having to jump to the calculator or really strain about it is count the number of negative signs. So if there's an even number of negative signs, like here there's 0 negative signs, 0 is an even number, okay? So it ends up being a positive solution. 4 times 4 times 4, or sorry, that's 4 plus -4 plus -4 plus -4. So 3 times -4 gives us -12 because I have one negative symbol. 1 is an odd number, so 3 times -4 gives me a negative solution. And again, the properties that apply multiplication also apply to division, since division and multiplication are the same priority. And really, when we divide by 2, it's multiplying by 1/2, so we can think of them the same. So if everything's positive, the solution's positive. If we have one negative sign, we have a negative answer. If we have 2 negative signs, then we have a positive answer. We have two negative signs with a positive answer. So just be aware of that. And it doesn't matter when we're doing division. So if I have like negative 15 divided by 3, that's negative 5. But what about 15 divided by negative 3? It's still negative 5. So when we see fractions, like if we're saying negative 1/2, sometimes we'll see it written as negative 1/2. Sometimes it'll be even with this division bar, negative 1/2, or we could even write it as negative 1/2 that way if we wanted to. So we'll see it sometimes in different forms. Again, the key is we have one negative symbol, one negative symbol, and one negative symbol, so it's a negative number. Up here, if we did negative 15 divided by negative 3, well, that becomes now positive 5. Negative 15 divided by negative 3, that becomes positive. So just be aware of that. The ones we see today will mostly be one or two signs, but the properties apply down the road for if you have 7 negative symbols. We're not going to see any of that complex, but if we're multiplying and dividing 7 different numbers and they all have negative signs, well, 7's an odd number, so the solution's going to be negative. If we have 8 negative signs, well, 8's an even number, so the solution, whatever it may be, is going to be positive. So it's just something that we can look for. And then this rule is same sign, the answer is positive. Different signs, the answer is negative. So kind of another way to think about what we were talking about. Okay, to calculate these, 8 times 4 is 32. 8 divided by 4 is 2. Again, I don't love this because it almost makes it look more like, it does make it look more confusing with all these parentheses and extra symbols. If I just said 8 divided by 4, again, you'd probably answer without even thinking. And they put the plus 2. If you do, I'm not going to mark it wrong, but I would prefer you didn't, just for simplicity's sake. If it's 2, we know it's positive. 8 times negative 4 is negative 32 because we have one negative symbol. Negative 8 times positive 4, again, one negative symbol, it's still negative 32. It doesn't matter if the negative comes first or second. There's one negative sign, and we're multiplying. It's a negative solution. Negative 8 times negative 4, negative times a negative makes it positive. 2 negative signs, 2 is an even number, so it's positive 32. Back over here, 8 divided by negative 4, one negative sign, so it's negative 2. Negative 8 divided by 4, negative 2 still. Negative 8 divided by negative 4, negative and a negative make positive. And then we'll work on these when we get to class. So that's the big thing. Just remember the rules. I know you guys know how to multiply and divide very well, so I'm not worried about that. It's just now we're introducing negative symbols, sometimes 1, sometimes 2, down the road even more, and that's what can trip you up. But just pay attention to the signs and understand when it's going to be positive, when it's going to be negative, and obviously use the calculator to help you as well. Right, lesson 113, we're adding and subtracting mixed measures and multiplying by powers of 10. So mixed measures, the hike from the trailhead to the waterfall took an hour and 50 minutes, and an hour and 40 to return. How many hours did it take altogether? Well, we're adding, what was it, 1 hour, so that should be at the end, 1 hour and 50 minutes there, an hour and 40 minutes back. What was the total time? And we're going to add these together. Okay, again, just like regular numbers, we start all the way to the ones place, or the furthest to the right. It's the same thing as this. We're going to start with minutes. 50 plus 40 is 90 minutes. 1 hour plus hours, 2 hours. But it doesn't really make sense to say 2 hours and 90 minutes. Since 90 minutes, we can rewrite as 1 hour and 30 minutes. And then we add this hour back here, so 3 hours and 30 minutes. Or if we wanted to keep it just as hours, since 30 minutes is half an hour, we could say 3.5 hours. Okay, looking at example 2. The measure is vertical leap. Tyrone first reaches as high as he can against the wall. He reaches 6 feet 9 inches. Then he puts chalk on his fingertips and jumps as high as he can and he slaps the wall. So you've probably seen this like at workouts or NFL combine or something where they're trying to test people's vertical. They'll have them reach up to know how far they can reach without leaving the ground, and then they'll have them leave the ground and see how high they can touch, either by touching the wall, or they have those little pegs that spin when they touch it, it moves, so that way they know how high they got. Obviously, if they didn't touch it, it didn't move, so they didn't get that high. But in this case, he's doing chalk on his fingertips and jumping as high as he can. The top of the chalk was 8 feet 7 inches. How high was he off the ground? So this one we're going to do subtraction. So 8 feet 7 inches minus 6 feet 9 inches. Yeah, 6 feet. Okay, so again, we start all the way to the right. And just like with other subtraction problems, we sometimes have to borrow from the next place value over. We may have to do this, not always, but we may have to do that in this example. So 7 minus 9, 7 inches minus 9 inches. Well, that's a negative number, so I can't do that. I have a negative vertical, hopefully. So what we're going to do is we're going to borrow a foot from here. So I'll take a foot away. So it's now at 7 feet. It's 7 inches plus 12 inches. And I add a foot or 12 inches to this. 12 plus 7 is now 19 inches. So we'll go 19 minus 9 is 10 inches. 7 feet minus 6 feet is 1 foot. So 1 foot 10 inches, or 22 inch vertical. Usually people do the vertical in inches, but it's a 1 foot 10 inches. All right, powers of 10, we use this a lot in scientific notation. The thing about anything powers of 10 is it's just 1 and then however many zeros after it. So there's some consistent rules that we can apply to it, and we're just moving the decimal right, or if we're dividing by 10, 100,000, whatever, moving the decimal to the left. So if we have this number and we want to write it in standard notation, well, we could get our calculator and do what is 1.2 times 10 cubed. We could do that, or we can just remember, well, 10 to the power of 3 means it's going to be 1,000. I'm going to have 3 zeros. 3 zeros means I'm going to move this decimal 3 places to the right, and it's now 1,200. So if I have 6.2, for example, 3 times 10 squared, this is going to be 2 zeros, 100. Now I have 6.2 times 100. These 2 zeros, or this 2 exponent, gives me my hint of how many times I move this decimal 2 places to the right. So it's 620. Half a billion in standard notation. So half is called 5 times a billion. So 50 million, zeros, thousands, millions, billions. Okay. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So I could really think of this as, and I could just write out 500 million and do half of this. But we'll show you the concept. So this could also be written as 10 to the power of 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So to the power of 9 means I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9. And fill in zeros for all those spaces. So 1 here, 1, 2, 3. So we get 500 million. yards as a class. The last one we're looking at for this week is unit multipliers. And we've used these quite a bit. You probably use them even sometimes in your head, like if you're converting, this is 2 feet. How many inches is that? Oh, it's 12 inches. And a foot, so 2 feet would be 24 inches. So you just use a unit multiplier, even though you maybe don't draw it out and show the cancellation of units and things like that. It is what you're doing. So the unit multiplier is something that's just technically equal to 1 because it's just itself over itself. Just like 5 over 5 is 1, 10 over 10 is 1. Well, 1 foot over 12 inches, that's the same length, or 12 inches over 1 foot. So it's technically equal to 1. When we're talking about using the unit multiplier, we're converting units, but we're not making it larger or smaller, the distance greater or shorter, or anything like that. As I said, if I said, well, 60 inches, how many feet is that? You probably just do 60 divided by 12 and get 5 feet right away. And what you're doing when you do that, well, a unit multiplier, 1 foot is equal to 12 inches. I want inches in the denominator because it's in the numerator right here. And I want inches and inches to cancel out because I want to be left with feet. So I factor 12 out of both of these. I'm left with 5 times 1 foot, which is 5 feet over just 1. So we just write as 5 feet. Okay, so for this, 3 feet is 1 yard, and we're going to put that. We know that's true. 1 yard is equal to 3 feet, and 3 feet is equal to 1 yard. We can put that in a unit multiplier, and we can write it 2 different ways. I can say 3 feet over 1 yard. I can also say 1 yard over 3 feet. It just depends on what the question is asking down the road. Do I want to end up with yards in my solution? Then I want yards in the numerator. Do I want to end up with feet in my solution? Then I want feet in the numerator. And what we're trying to cancel out will help determine that. Example 2, we're going to use this unit multiplier, so we'll keep those up. But those are the different ones. If we want to convert 30 yards to feet, 30 yards, I want to end up with feet. And so I want to get rid of yards in the numerator, so I want to have yards in the denominator down here. Just like any number over itself cancels out, well, any unit over itself also cancels out. 1 yard is equal to 3 feet. Right? So again, if I said 30 yards is how many feet, you may just mentally, without doing any of this, say, oh, it's 90 feet. But what we're doing when we do this, more and more examples that are more complicated, sometimes we'll use 2 or 3 unit multipliers, so you get a better idea of this. These are pretty basic examples just to show you the properties behind it. So yards and yards cancel out. I'm left with 30 times 3 feet, which is 90 feet divided by 1, which is just 90 feet. Example 2, we want to convert 30 feet to yards. So 30 feet, I'm going to end up with yards. So I know right away, what do I do? Feet up top or in the bottom? Well, feet is in the numerator here, so I want to cancel it out. So I know it goes into the denominator down here. I want to end up with yards in my solution, so that's why it goes up top here. Okay. And then just make sure you remember 3 feet is equal to 1 yard. If there's ever like ounces to pounds or grams to milligrams or something like that, you're not sure. This is where the reference sheet comes in handy because you can just compare what things you're trying to convert, and it'll make it easier. Inches, feet, yards, I think are pretty simple. We know most of those, but some of them you may have to look up. So feet and feet are going to cancel out. 3 and 30 have a common factor of 3. So 10 times 1 yard is 10 yards. Again, you probably did it without even thinking. 30 feet is how many yards? 30 feet divided by 3, it's 10 yards. Okay? And that's what we're doing. Again, we'll see some ones that are more complex, but that gives you an introduction to the concept that's going on when we have that. And we'll do those practice set problems as a group. That is it, because we're going to do 115 the following week. We'll see you guys.